Alright everyone, welcome to a whole new week of computer science. So, the next linked list competency exam is up. For it, you only have to write a function. I don't want to see you guys writing an entire class. You just have to write a member function for the linked list class. So, just don't. Like if you write the whole thing, I'm not going to give you the point on it. Just write the function. That's it. Okay. So, yeah, if you're going to transfer, Berkeley is a good choice, I guess. San Diego. I like going to UCSD a lot. UCSD Computer Science is pretty good. I've had students go to UCLA also, and they liked it. So, what do you mean only member function? So, like when you have a class, then class.cc. So let's say you're making a class linked list, public section. So if I'm going to make a function called, I don't know, sum up or something, returning, I guess an int, you're only going to write this part here, right? Don't write the entire class. Just write the member function. Okay. These quizzes are time limited, and so this time I tried to restrict how much coding you actually have to do. So don't write the entire linked list class. Don't copy and paste it, because that indicates to me you don't know what you're doing, right? You're just like, I'm just going to copy everything and hope what you're asking for is in there. No, just write that bit right there. It's not this, obviously, but just write that part. For linked list. Yeah, for BST, that is going to be coming up, but I want to get through linked list before we do the BST one. We're not quite done with BSTs yet. So, so your homework is due on Friday, I believe, right? Dungeon Delve. And for that, you're going to have to make a binary search tree. You're going to read in a bunch of letters and build a binary search tree out of the letters that represents the dungeon. And then the users can input some letters to search for. You're just going to output the path you take through the dungeon. So this is going to test your ability to create and search binary search trees. The circles point class confuses every time it's asked to be written in pass-Cs. Yeah, I mean, yeah, because they're, because that was the class competency exam, right? Like, show me that you can make a class. Right? So if you're gonna make a circle class, let's not do circles again. Circles are easy. Give me an idea for a class. Give me an idea for class. Something we're gonna represent. How would you visualize Dungeon Delve in Bridges? Great question. So Bridges has. Let me get to that in a bit. Remind me if I forget, Sarah. Polygon. Ew. Okay. All right. So for a polygon, if we're going to do this using proper class design, polygon. All right. All right. So let's do 2D polygons, I guess, because I don't do 3D. So we're going to have a point, and we'll just have it be a struct, and it'll just have an X and a Y location, I guess. So polygon is going to be 3 or more points. So how do you represent that? That's a good question. It's tricky. It's tricky. 3D polygons or polyhedrons. Yeah, but you have to enforce the fact you have to have 3 or more points, right? You can't just take a vector of points as the constructor, and you can't have a default constructor either, right? So internally, sure, we're gonna have a vector of points, point called points, and that's gonna be what points are in the polygon. Public. I don't think we can have a default constructor because you have there's gonna be a class invariant, right? Good choice of thing though. So what kind of class invariants do we have? What things must always be true about a polygon? What do you guys think? And this actually might be more tricky than you realize. Yeah, so no default constructor. Yeah, so polygon equals delete. So no default constructor. If you try making a default constructed polygon, if we try saying polygon poly like that, boom, won't compile. Why? Because we've deleted the default constructor. Okay. If we take that out, it'll generate one for you, right? So you can delete it. That way you can't have a default constructed polygon. It's probably a good thing, because it doesn't make sense to have a zero-sided polygon, right? So vertical line test or such, interesting. So you're saying for every vertical line, it can only intersect the polygon twice, right? Is that what you're saying? Yeah. So as it turns out, what you're trying to say there, Ephraim, is you want a simple polygon. A simple polygon is one where the lines don't intersect each other, right? And that actually makes for a very nice set of properties. Like you can compute a lot of things using computational geometry. You can do with simple polygons. Can otherwise. Okay, so one invariant is 3 or more points. Must be simple. No self-intersection. What else? Width and length. Interesting. What do you mean by width and length? It's like, what's the width and length of a hexagon? Or do you mean like have a bounding box that kind of encapsulates it? Something like that? Make it so the size of the lines are all equal? Okay. All right, so we're going with the sort of, what are they called? Platonic forms, triangle, square, pentagon, hexagon, equal-sided. Okay. All right, like, you guys have to tell me, like, you know, you just said polygon, so do you want a simple polygon, complex polygon, or do you want to just like a Platonic ideal, which would make life actually pretty easy? Equilateral. What do you think? What do you guys want? And it's always a good idea to start by writing down what the rules are for your class, you know. That way it guides the design of your class. To make it complex, harder equals more learning. You're making my life harder, man. All right. Complex. Jeez. All right. All right. We'll allow complex polygons. All right. All right. Degrees of angles. It's not really an invariant, right? It's not a rule that must always be true. We can compute the angles, but I don't know if that's a rule that must always be true. You know, I mean, I guess we could put that in there and then create an invariant for it. Imaginary polygons, I don't know. So these two things are contradictory to each other. So you guys vote. Do you want? It's 3 options, or you guys have to pick one of these. Which one of these 3 do you guys want? Which one do you guys want? Take a vote. So simple polygon is one that the lines don't cross each other. Complex polygon, they can. And then for Platonic ideal, it's like square, equal-sided pentagon, equal-sided hexagon, you know, that kind of stuff. Whatever is easier. I don't know which is easier at this point. It's simple. All right. Platonic. Simple. All right. Simple it is. All right. So how do we do a constructor for this? Polygon taking in a vector of points. Yeah. Okay. So let's say that we are going to pass in, and we are going to pass in here the point 0, 0, 0, the point 10, 0, the point 5, 5. So this is going to be an equilateral triangle, I think, right? Maybe not. No, I don't know. Something like that. It's gonna be a triangle. It's isosceles probably. And why do you not like this? No matching constructor. All right. Well, say a vector of point. No matching constructor for vector of points. Because it's int. That works. All right. So that works. Did I just have like a missing thing before? That works. Okay. That works. All right. Polygon shape, passing in P. That works. Okay. Yank to the end of the line. Paste. Does not like that. Vector of point. Huh. It doesn't want to construct it. Weird. Huh. Oh, no, this needs to be. Yeah. Okay. Well, let's have a discussion about the big O of this. I'll worry about the syntax later. Okay, so what is the big O running time of this constructor here? We are passing in a vector of points that has n elements in it. How many operations does it need to do? What is the big O running time of the constructor here? All right, n. Cool. Why is it n? Why is it n? Vector is not an answer. Why is it order n? What are we doing n times? If we pass in a billion elements, what operation are we doing a billion times? It's going to go through the whole vector and what? What's it doing? Thought it'd be order 0? No, this is order n. Order 0 is the only order 0 thing we've seen is sorting a binary search tree, and that's because you literally can't write code to do it. So this is order n, and the reason for it is because what? Insert? Inserting what? Vector has to go through each element to make space for the new element. Copying a vector. Okay. All right. What's the running time of it now? Assuming the optimizer doesn't change anything. What is the running time of this function now? Order 1? Order 0? There's no lines of code inside of the function. Order n? How much work is this code going to do? Order confuse? Order should not be confusing. I mean, I understand it is, but it shouldn't be. You need to understand how much work is taking place here. It's not doing anything, is it? It is. This function is doing order n work. Where? Where is it doing order n work? Isn't it copying? Very good, Grace. Exactly. What's happening is this vector here is a copy. I did not pass it by const reference like I normally do. Right? So in order to get new points, it is going to copy all n elements from P into new points and then do nothing. So this is actually where it is order n. Okay. The running time of this is now order 1. When you pass something by reference, it passes a pointer behind the scenes. It passes a pointer, and that's it. So P itself is now passed in, rather than a copy of P. By default, when you do this, it makes a copy. That's call by value. Call by value means copy it, make a doppelganger, make a duplicate of it. And so this is going to duplicate the vector. So all n elements in the vector are going to get duplicated into a new vector, and then it'll do nothing with it, and it'll go away, and it'll go through and unallocate all of them, and it's a giant waste of time. It's pointless, but it's still order n. That's why I said the optimizer, assuming the optimizer isn't going to step in here, because the optimizer could look at that and be like, yeah, we're not doing anything. That said, if a constructor has side effects, then maybe it would do it anyway. I don't know. But this is order 1 now, right? Because now we're passing in just a pointer to P. We're not doing anything, and we return. So, third question. And let's get Watkins and Yui and Yoxtheimer. Let's get you guys answering this one, okay? This is, remember, participation is mandatory in this class, okay? Just saying good morning doesn't count. You gotta participate in class at least once per day. What's running time now? What's the running time now? Order n squared? Why would it be n squared? If it was copying twice, that would just be 2n, not n squared. N squared would mean like for every element in the vector, copy all the elements of the vector, right? That would be like, if you want to do an n squared thing, it'd be like for size ti equals 0, I is less than new points dot size I plus yyp right shift that, see out. Right. Now it's in square. But we are not doing something for each letter in the thing, for each letter in nah. We're out. This is either going to be 1 or n. You know, those are the two. Those are the two options. It's not going to be log n. It's not going to be exponential. You got 2 options here. Okay. So Muya says it has to do a deep copy. Interesting. Okay. So, yeah. So this is going to be order what? Order n. If it's got to go through and copy all the elements from new points into points, then it's order n. But just throwing this out here, what if we did a shallow copy instead? What if p isn't used after this point? Right? We don't use p anymore. And so we don't need to do a deep copy, and we could do a shallow copy instead. This is something called a move constructor. Okay? And a move constructor deliberately does a shallow copy. All right? And it'll do a shallow copy. Do you guys remember the difference between a shallow copy and a deep copy? Shallow copy means it just copies the pointer to the internal array. Deep copy means it goes through each element in new points and push backs them into the new guy. Okay. So, if C++ can determine that new points is not used after this point, then it will actually do a shallow copy. It'll actually just steal it. Okay. It's not using pushback, you know what I mean. So it is not actually doing a copy of all the elements. It is going to actually steal it. So if you is this just another name for the same vector in memory? So if you do this, you say vector Shift O. What's going on here? Shift O. Thank you. If I say vector of points Q is equal to P, is that order n or order 1? What do you guys think? Let's see what CPP reference has to say. Where are the constructors? Constructors. Constructors. Move constructor. Okay. Or the new one. This one. Okay. Move constructor constructs the container with the contents of another using move semantics. So WTF does that mean? What is move semantics? What is move semantics? Well, Allocator is obtained by move construction from the allocator belonging to the other. After the move, the other is guaranteed to be empty. So what is happening here is if C++ can determine that one vector is going to sort of replace the other one, like if you return a vector from something, from a function, that vector is no longer ever going to exist, right? So if we're going to be returning a vector of points from a function called foo, you would think this would be order n, but you would be wrong. Okay, why? What the hell, right? So C++ has, in C++ 11, it added this feature. So prior to C++ 11, all of you guys that said order n would be correct, because the best it could do is just copying all the elements out. However, C++ has something called move semantics. Move semantics mean that if you don't need the right-hand side anymore, it will do a shallow copy and purge the right-hand side sometimes. Sometimes. Okay? So in this case, it's pretty obvious the right-hand side is not going to exist anymore, right? The right-hand side doesn't even have a name. The right-hand side refers to the right-hand side of the equals, right? So foo is returning a vector, right? And that vector is going to go away. Like if all we did was call foo like this, do you guys see that? This is going to make a vector and return it, and the return value isn't used anywhere. And so it'll just immediately get deallocated. The destructor will get called on it. So when you do something like this, there's an optimization. So move semantics is an optimization, meaning don't copy if you don't need to. Steal instead. Because remember, all a vector is, right? Let's go to the notepad here. All a vector is what does the vector class look like? The vector class looks like this. Yeah, the overall vector class called vector, and inside of it, it's got some sort of R pointer to some chunk of memory. It's got a size t called size or something like that. Holds how big it is. Actually, it doesn't. It's thing actually. I think internally, it just has a pair of iterators. So it's going to have an iterator for the beginning, for the end. So the beginning iterator points at the chunk of memory there. The ending points there. I don't even think we have that, honestly. I think that's really all the vector is. It's just a pointer to the beginning of a chunk of memory, the pointer to the... But it's also got one other thing, because vectors over-allocate memory. So if you've got, let's say, 5 guys inserted in here, 1, 2, 3, 4, 5, then there's also a kind of a current pointer that says, hey, here's where we currently are within the chunk of array we own. And so if you were to call pushback would write here. That's where current was pointing. And then the current pointer would move to here. Okay. You call pushback again. It gets written there. It's currently pointing there. If you call pushback again, our array is full. So what happens when the internal array inside of a vector fills up? What happens? What do? Pushback's supposed to be order 1, right? Not always. Not always. Download more RAM. It makes a new space. Now, when you allocate memory, when you call new, it would be really neat if you could like allocate it there, right? Unfortunately, new doesn't work that way. New, when you call new, it will just give you some chunk of memory that it can find somewhere in RAM. You can't, unfortunately, specify, give me this memory, because after all, this could be used for like X and Y and other variables, things like that, right? New vector gets created twice the size and copies all the elements. That's a good way of thinking of it. Okay, it doesn't have to be twice the size. It could be like 1.5 times the size, but that's, you know, the general way of thinking of it. So what happens, it'll call new, and new is going to return a chunk of memory twice as big as before. Not to scale, by the way. And then what? Then what? So it's going to new this chunk of memory down here. Then what? It's not going to be order n squared. No, definitely not. Copy all the elements. Order in. Yeah. So it's going to copy 1, 2, 3, 4, 5, 6, 7, 8. Once it's been copied, it will deallocate all of this memory. That is most definitely an order n operation. You need to understand that, right? There's n elements in the array, so it copies n elements over. It's n operations. The beginning pointer is now set to be here. The ending pointer is now set to be the end. Well, not using the right terminology bugs me. The secret end pointer is set to be here, and the actual end pointer, which I've been calling current, is set to be here, which is technically the end pointer. The end pointer is actually pointing here, and there's an internal end pointer there. But using the terminology I just used, that's what it would look like. And then it would insert 9, and then the current pointer would move to here. Okay. So do you guys understand? It bugs me. I'm gonna fix this. So actually, that's the end pointer. And then there is a secret pointer that points here. That's the proper terminology. Okay. So if you ever call size, like if you say, hey, what is the size of this vector? It does this. It says end minus begin. So it subtracts the 2 pointers, and then this will have, they're off by 1 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's correct. So it'll subtract n minus begin, and it'll give you 9. So begin is pointing here. All right. Are you guys with me on this? Yeah, n squared would be like if I said for each element in the array, do something across all the elements of the array. That'd be n squared. You're rarely going to see an order n squared copying from one to another or something like that. Usually when you copy from one to another, it's order n because you're just copying all the elements. So you gotta internalize these things. Rohan is with you. We ride for Gondor. The beacons are lit. Okay, so was this the focus of today's lecture? Yeah, move semantics was the focus of today's lecture. So, but I'm explaining how vectors work just so you guys understand what's happening behind the scenes. Because you use vectors a lot, so it's probably worthwhile knowing what is actually happening behind the scenes. So, inside of a vector, there is a function called reserve. Here. Okay. So if I were to call a reserve 1,000, what would happen is it would allocate, it would do this whole process we just did there again, and it would make the secret pointer pointing at like begin plus 1,000. So if you call dot reserve on a vector, if you call dot reserve 1,000, like vec dot reserve 1,000, what will happen is that is telling C++, hey, I'm planning on having about 1,000 elements in this vector. So it doesn't change begin, it doesn't change end. Instead, what happens is it'll do a reallocation. It'll new, I don't want to redraw this, but it'll do a new, it'll copy all the elements over, but the amount of memory it allocates is big enough to hold 1,000 elements at least. And so you do this in order to avoid reallocations, right? Because if I were to go 10, 11, 12, 13, 14, 15, 16, then it triggers reallocate. Then it's going to reallocate again at 32. It's going to reallocate again at 64. It's going to reallocate again at 128, 256, 512. Okay, and so those are all unnecessary copies. And so if you call vec.reserve 1,000, you can get a nice speed increase by it'll just reallocate one time, make enough room for it. You can waste memory, this way. If you say reserve 1 billion elements and you're only going to use 10, you're wasting RAM. But this is a nice function to know. So no, the point of today is the move constructor. Move constructor. So move constructor. Let's see if we have an example in the CPP reference. And there's also move assignment operator. So if you say x equals y, and C++ knows, do you see that double? Do you see the double ampersand there? The double ampersand here, the double ampersand there. That was added in C++ 11. Okay, and so what the double ampersand means, it's a move assignment operator is what it's called. And so the move assignment operator says, call this function when you know the person that I'm copying from isn't going to be used anymore. And for example, that would be when you have a thing like this. This guy will never be used after foo has returned, right? It's gone, it's dead, it's going away, it's dying. And so C++ knows this is going away, and so this will call the move constructor on the vector, or the move assignment operator on the in this case it would be a constructor because it's constructing a new vector of points. But if afterwards we said q equals foo, this would call the move assignment operator. This is order 1 because it could call it, if you don't have a move assignment operator, it will call the copy constructor. It will call the copy constructor and it will be order n. But because the people who make the standard library have a move assignment and a move constructor in the class, what happens is this. So back to the blackboard, kokuban, as they say in Japanese. I just learned kokuban, the blackboard. What happens is this. We're making a new vector, right? So we're making, what was our old one called? Our old one was called P. We're now making a vector, so we're going to call this guy over here P. And we're going to make a new vector called Q. Making Q. Okay, Q is currently empty. It's being constructed. What does it do? C++ can say P is going away. And so rather than doing the following operations, copy P to Q, and then delete P, right? Because this is, with what you guys know right now, this is what it would do. It would copy P to Q and then delete P. That's wasteful. You don't need to do that. Instead, rather than doing a copy of P to Q and then deleting P, what it does is it will move. What it will do instead is it will do a move from P to Q. Okay? And what a move does is this. Q's got a begin, Q's got a begin, Q's got an end, Q's got a secret pointer. It doesn't have any memory allocated yet, so I probably shouldn't even draw this, but whatever, there's nothing. It's brand new, it's a brand new vector. What it does is this. Begin pointer, choo, psh, end pointer, choo, secret pointer, choo. And then on P, it's like, you're no longer pointing at you, you're no longer pointing at you, you're no longer pointing at you. Done, drop the mic, walk away. So our begin pointer is now pointing here. Order one. It's 3 operations. Vector dot, so Q's begin gets set equal to P's begin, Q's end gets set equal to P's end, Q's secret gets set equal to P's secret, and then P's values are all set to null, basically. That's it. 6 operations. So rather than having to copy a billion elements and then delete a billion elements, 6 operations. Do you guys see how that's nice? This was a very important addition they made to the language. Vector is a reference to reference? Nope. It is a new thing. It is a new thing. It is not called by reference. Good question. That's what it looks like. This looks like a reference to a reference. It is not. This means move. So it is called when the C++ compiler knows other is not going to be used ever again. You can call it manually. There's a standard library function called move that can call it manually. If you need to tell it, hey, I'm not using this thing anymore, move the internal pointers into somebody else. You can call std move. Std move. All right. So if you have a string and a vector of strings, you can move the internal pointer of a string into the vector. That way it doesn't have to copy all the elements of the string. What will happen is the vector will make a new string, and its internal pointer will it'll steal the internal pointer of str. So the internal pointer is, I'm pointing at that guy, and then that guy no longer points at it, and you've stolen its memory. So you can steal memory in order one time rather than having to go through and copy all of the letters out of it. You can't use stir anymore. If you've done that, stir is now dead. You should not use stir again. Honestly, there are some guaranteed behaviors of things that have been moved out of. In general, though, you should never, as just a general rule of thumb, you should never use stir once you've moved out of it, because its internal guts have been ripped out of it. Right? It had an internal pointer to this thing and an end pointer, and all those pointers have been stolen. And you probably should not. Yeah. Clearing it's okay. Erasing it's okay. Starting over probably work. In general, though, I don't use a variable after I've moved out of it. And most of the time, you don't need to call move in a lot of cases anyway. The compiler will actually figure it out. So a lot of times the optimizer will do the move for you. So, all right. So do you guys see that? So this is a order 1. So rather than doing an order n copy, this is an order 1 move. Okay. What's the point of pointers to pointers of something? Happens. What if you want to change a pointer? You pass it to something, and if you pass a pointer by value, it's a copy of the pointer. So if you want to change a pointer, you pass it to somebody, you pass it as a pointer to a pointer, or reference to a pointer. Put into a function that we can do this move semantics. No, you don't need to. And that's so if we did this, this should call the move assignment operator, because P is not being used after this point. So if the optimizer looks at that and goes like, yeah, that's the swan song for P. P's going away after that point. P's not used anymore. Don't call the copy assignment operator. Call the move assignment operator, and so it'll steal the guts of P and put it into Q. So it'll first destroy its old array. So it had an old array here, right? So when it does that, it'll first have to free up all of its own memory and call the destructor and all the elements in it, if need be, and then it will just steal the guts of this one. So its internal pointers will be the internal pointers of P. And like I said, a lot of the time you don't need to call std move. This is all invisible. Like if you use the vector, if you use vectors, basically just like if you use vectors, which you should, because they're the vanilla ice cream of data structures, it'll just call move when it can. Anytime it makes sense to use move, it'll move. And you'll have an order 1 copy instead of an order n copy. So that's the good news. The good news is a lot of times you just don't even have to worry about it. A lot of people worry though about doing something like this because I'm returning a copy. I'm returning a copy of a vector, so they think it's going to copy. If you make 1 million elements in here, it's going to have to copy 1 million elements out. It's going to move out of it. So there's no overhead. And what's worse, when people don't know about move semantics, they try optimizing, right? So they're going to try returning by reference, which you can do. You can do that. What the hell does that mean? What does it mean when you turn a reference to something? Yeah, I was supposed to cover it in your class, Muy, and I forgot. So there is something called the rule of 5. The rule of 5 is that if you are allocating memory or other resources, network sockets, files, things like that, in your constructor, you will probably need these. So there is the rule of 0, the rule of 3, and the rule of 5. Destructor. You guys remember the rule of 3? The first 3 are the same. What are the 3 elements of the rule of 3? The rule of 5, the first 3 are the same. If you're going to be newing memory in a constructor, what 3 things should you probably have or delete? Copy constructor, good. What else? Destructor, constructor, copy? No. That's why the rule of 3 is badly named. If you're allocating memory, it should be in the constructor. And if you have memory allocation in the constructor, what 3 things in addition to it do you need? So it's actually really the rule of 4 because it's constructor, destructor, copy constructor, and we already got delete. And what else? Assignment operator. Okay. The rule of 5 adds these 2. But they're optional. The move constructor, which looks like this. Polygon, reference, key. and the move assignment operator. This operator equal sign that again has a polygon reference in it. And so the move constructor and the move operator get called when C++ can determine that the thing that you're copying from isn't used anymore. If you don't have 4 and 5, it's not the end of the world. It's not the end of the world. It will default to using the copy operations. So if you were to make your own vector class and you didn't make the move copy constructor, the move assignment operator, it'll just call the copy constructor. It's not the end of the world. You're going to get hit by order n when it could be order 1. Not the end of the world. Yeah, it's just inefficient. Okay. So this is called the rule of 5. So if you're allocating memory in RAM, then you need destructor, copy constructor, operator equals, move constructor, and move assignment. I, however, prefer the rule of 0. Rule of 0. Don't do any of these. Okay. Don't allocate memory in a constructor. Don't allocate memory at all. I don't like allocating memory these days. I use a vector. Right? Because I'm using a vector, my polygon class does not need new. I don't need to make a destructor for it. There's an implicit destructor. In my class, the implicit destructor will call the destructor on points and handle it for me. I'm not going to leak memory. I'm not going to corrupt memory. I'm not going to have a use after free. I'm not going to have a double delete. None of that. Because I use a vector to hold my points, it's just handled. It's nice. Okay. So when I code these days, unless I'm making a data structure, in which case, if you're making the vector class, you're going to have to use new and delete and, move constructors to steal things. And, there's a fair bit of, nonsense. It's not really nonsense, but there's a fair bit of rigmarole you have to go through to make a good data structure. Most of the time, if I'm making a video game that will involve submarines hunting each other, there's no news anywhere in my code, right? So like I made a video game, quote unquote video game, no, real video game, I guess. Not very fun video game. It was a class assignment, but it's called Captain Sonar. It's based on the board game of the same name. And using CMake for this one. Cool, check me out. All right. It's called Sonar. Title screen's not big. I made a title screen for it in ASCII art. I'm gonna have to shrink the font size down. There we go. There we go. I made some ASCII art. Captain Sonar. It's got a little submarine here. So if I'm going to be making a game about submarines, how many players, so there's a map of the world, and the submarine has a location. I'm going to start at A1, and then the other person chooses their starting location, H3, and it's got health and torpedoes and sensors locations. If I had to make a class for this, my class would have a location, torpedoes, sensors, health. It's going to track your movement, and so that would be a vector. So if you were to look at my class, wherever you are there. So the submarine class, I did it pod style. It's got some constants, it's got some variables, it's got a vector. There's no constructor, there's no destructor, there's no copy constructor, there's no move copy constructor, move constructor, there's no assignment operator, there's no move assignment operator, none of the above. It just says what a submarine is, and it uses a vector to hold the dynamic memory stuff because it's as you travel around, it leaves a trace of where you are. Because Captain Sunner, I don't know if you guys have ever played the board game this is based on, but that's how the board game works. Is you determine where the person is based on the history of their movement, and so you have to dynamically allocate memory. There's a map of the world like this, and then you have a radio guy that is writing down. They moved east, they moved east, they moved south, they moved south, and they have this like transparent sheet of plastic that the person's writing moves on, because they're listening. There's a border down the center of the table, and the radar person is just listening to the other people talk. And so you can't whisper, by the way. You have to talk. Move east. All right, moving east. Yeah, like this here. And so you can see right here you have the sonar person, and so they're sliding that sheet of paper. That's their actual route, and then the person over here has been writing down their moves. No, that's the radar person. But they write down their moves, and then they slide a piece of paper with their moves on it, trying to see what possible spots they can move on, be on. So it requires dynamic memory allocation and deallocation. When they surface, you erase their move history. And I don't do any of that. If I need to erase the move history, I call vector.clear. Do it for me. Okay? That's the rule of 0. So all of that stuff, there's a lot of complex things going on there. And I can't leak memory. I can't use after free. I don't mess with pointers. I don't mess with move operators or constructors or deallocating memory. I call pushback and I call clear. Pushback adds things to the vector. Clear erases all the elements of the vector. Done. That's the rule of 0. Okay? So you use the rule of 3 or 5 when you are calling new or allocating some other resource. For example, if you use, if your class has got an open file, then your destructor needs to close the file, right? Or not, because the default destructor will close it for you. If you're opening a network socket in your constructor, then your destructor needs to close the network socket. If you leave a network socket open, then you can't use that port again for 5 minutes, which is really annoying when you're doing the server. So you want to make it so when you quit your server, it closes all the sockets down. Then you can run the server again without having to wait for 5 minutes, which is really annoying. Okay, so let's go back into here. And so that is the rule of 0 and the rule of 5, which is our learning points for today. Why is this bad? Why is it bad to return a reference to a local variable? Why is it bad to return a pointer to a variable that doesn't exist anymore? Why is this bad? Why is it bad to return a pointer to a stack allocated variable that doesn't exist anymore? It's going to be a use after free guaranteed. Yeah. So this vector is gone. When we hit the close bracket there, that vector has been destroyed. And we are returning a pointer to a variable that has been deallocated. So this down here looks cool. Looks like we're yeah, we're returning it by reference. Oof, I don't know. It might copy out. Make that a reference, then it's going to be just double extra ungood. Was it p.x, p.y? Let's see if we can get this to crash. Warning. Yeah, warning. As I've told you guys before, don't ignore warnings. This returning a pointer to a local variable is almost a surefire way of either seg faulting or having like just random things. This is an incredibly bad bug. It should not be a warning. This should be like, no. No. Don't do that. Right? But it'll just be a warning. And a lot of new programmers are like, oh, a warning. I can ignore that. Seg fault core don't. Easy as that. Easy as that. If you return a pointer and the stack winds back up, you are now pointing outside of the stack. And easy segfault. Okay. Now, if we made this not a reference, let's see what happens. Will it copy? Will it move? Nope, segfault also. Good. Good. So that is a crash also. Returning, and a lot of students I've seen try doing this because they don't want to do a copy of the vector coming out. And as it turns out, you don't need to worry about it. because there's this thing called a move constructor. And C++ will be like, oh, P doesn't exist anymore. Rather than copy and delete, just move it. Okay. So move constructor will be called here. Move constructor replaces any copy plus delete, basically. So anytime you make a copy of an object and then delete the original object, C++, when it can detect that, will just move the object. Okay? You guys got it? Okay. So we are making a polygon. All right. Does not like this. Does not like this. It's passed by reference, maybe. Yeah. Const reference, it'll work. Because this is an rvalue. Okay. Okay. It might turn off the move constructor though. Either way. Okay, so that was a good learning point for today. What else can we do? Let's talk about proper class design. So, do I need a destructor here? What do you guys think? I've got a constructor. Do I need a destructor? Nope, I don't. Nope. Even though the word new appears here, that's not calling the new operator, right? The only time I would need a destructor is if I'm actually allocating memory or equivalent. Okay. So just because I call it new points doesn't mean it's actually newing the memory, right? Okay, so I don't need a destructor, I don't need a copy constructor, I don't need any of that. Rule 0. Leave it. Leave it alone. All of the defaults that C++ makes for you are exactly what we want. We're good. Okay. So, what kinds of things can we do with a polygon? So speaking of proper class design, what kinds of things can we do with a polygon? We can see if a point is inside of the polygon, maybe. Walker's here. He's like, did someone say computational geometry? I am there. All right. Did Muya tell you we're doing computational geometry, Walker? It is. It's fun. It's a lot of fun. So, how do you see if a point is inside of a polygon? So let's make a function called inside that takes a point by reference, so why not? And we want to return true or false if that point is inside of the polygon. Silence on the Discord channel. All right, let's make it easier. We're going to make it even simpler than simple. We're going to make it a complex, or a convex one. What is a convex polygon? So there's different kinds of polygons, right? And so what we had before was we had a simple polygon, which would include shapes like this.
This is mine.
Right? there's 4 different things. You can eat any of it. Can you bring me the iced tea, girl?
Okay.
And you're taking the old... Oh my gosh, look at this.
What?
Thank you, girl. That was very nice of you.
Oh.
I'm not being sarcastic. Yeah, thank you.
Do
Very
you
nice.
want me to throw this away?
Yeah, if you don't mind. Yeah, thank you. Wow. Cool. So this is a simple polygon. Right? You can have complicated polygons, right? This makes it even harder to work with, right? But even easier than simple. We rejected Platonic, right? Platonic would be just a square or something. But there's a very common form called a convex polygon.
What did you order from Namikaze exactly? Can you tell me the things you ordered?
I ordered Cali roll, tonkatsu ramen. Damn. Just draw the line there. There, call it a day. So it's not even. It's not a regular polygon. There is 4 different entrees. Just eat whichever ones you like. So this is called a convex. So a convex polygon is one that has the property of, from any point within the polygon, you can see all of the vertices. Okay. So that's a lot easier to work with. This, no. If you have a point inside of here, you can see some of the vertices. You can see some of the vertices, but you cannot see all of them. Okay. Inside of a convex, inside of a simple polygon, you can see at least 3. All right, probably 4, if I think about it. Okay. But inside of a convex polygon, you can see all of the vertices. So, is there a way of doing this in code? Doesn't this does not violate the horizontal line test? No. Each line that you draw through here touches the polygon at most twice. For this guy, the complicated one, yeah, exactly. This is not a simple polygon. Simple polygons are defined by oh right, yeah. Yeah, this is this is a self-intersecting polygon. Yeah. So yeah, this is a convex polygon. These are the easy ones to work with. Yeah, this is what we do in IS50B. So so how do we see if a point is within this? Well, I'll just give you the answer because I don't expect you to know that except for Muya and Walker that are in IS50B right now. So if you have a point here, and a point here, and a point here, you can see if it's inside by taking what's called the cross product. The cross product is x1, y2 minus x2, y1. If the number is negative, it's to the right. And so if all of your points are laid out in a clockwise fashion, then if all of the lines here have the point to the right, 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 if all of the lines agree that point is to the right, then it is within the polygon. Okay. And so that would be an order n test to see if a point is inside of the polygon. Rather than me writing it, because we are basically out of time, let me do it. Which assignment do we do that, you guys? A does not have almost any programming in it. The programming is all in what is called blueprints, and so in IS50A, you do cross product and dot product, but it looks like this. You're actually dragging and dropping boxes around, so it'll be like cross product. And you've got some vector 1, and you've got some vector 2, and you just drag the thing in like that, and then it spits out the result. And so it's all visual. Okay. For IS50A, we don't do any coding. Well, we do coding, but it's in blueprints, which is You know, you have the cross product, you feed the result of that into normalize, and you drag. You're literally dragging and connecting things around. It's like playing with Legos, but it's code. If you've ever done Scratch, that kind of thing. Okay. So 50 is closer to Java OOP. No, it's even easier. It's like Scratch, if you've ever used Scratch. It looks like this.
Use like kitties. And...
Like kitty stuff. Puppy personality test. See inside. It's probably going to be complicated, but whatever. So you just click and drag things around, right? So in Blueprints, there's a little line, and you connect the Lego blocks around. Okay. In IS50B, we do coding stuff. Sorry, girl, not right now. So yeah, I think Walker's posted the solution. So basically, you go through if you want to see if this point is inside of a convex hole, you cross product each of the lines with it. If all of them agree it's to the right, then it's inside the polygon. Congratulations. I'm not going to code it live right now. Seems easy. Yeah, it's not too bad. And so in IS50A, you learn kind of the tools of the trade, what is cross product, what is dot product, things like that. And then in 50B, we actually do real coding with it. Okay, so coming back into here, gonna play games for midterm questions. Yeah. So what was I? Class.cc. Okay. So the learning point today, by the way, was move constructor and move assignment. That's loading point for today. But I kind of wanted to go over proper class design kind of one more time. So I'm going to post the 4th take on class design. So remember, proper class design, rule of 5, rule of 3, rule of 0. Understand those. You should be able to write a simple class. This Polygon class, not so simple. I'm not going to make you do the inside function for a Polygon. Like I said, like these things can be difficult. Now, one thing we need to do here, just to come back to where we began an hour and 20 minutes ago, we need to enforce the rule that there is at least 3 points. So if new points dot size is less than 3, then we will throw a runtime exception. Must have 3 points. And this is in hashtag include exception. Is runtime exception in that one? To cppreference.com. It's the generic exception class. Roll and roll. Is an exception, but runtime error is in stood except. Love it. Love it. All right. Hashtag include. Oh, it's runtime error anyway. Stood except. And there we go. So if the user tries passing in a set of points, the polygon, and it does not have at least 3 points in it, then it's going to throw an exception. So what does throw do? Throw is a alternative way of returning from a function. It should only be used in anomalous circumstances. Don't use it as just like a synonym for return. What happens when you throw? Well, let's find out. Let's come down here. I don't care about you anymore. Let's comment you out. Let's comment you out. Okay. So put all these up here. All right, so let's say we have a function called foo, and foo returns an integer. And we'll take a boolean called should. So if should die is false, then we can default it to false. This is just demo code. You're not going to write code this way. So if should die is false, then we'll return 42. Otherwise, we don't need the else because we're returning. We'll throw a runtime error saying something bad happened. Okay. So if we call foo, if we just see out foo, what is this going to print to the screen? Is there two foos? Damn it, there's two foos. Damn it. Bar. There we go. Okay. What is this going to print to the screen? We're going to go over visualizing Dungeon Delve. Yes, thank you, Sarah. Yes. So what this is going to do, it's going to print out 42. And if we print out true, this will throw an exception. Because we did not catch an exception, it will kill the program, which will look like this. Boom, something bad happened. So if you do not catch an exception, it will kill the program. You can catch exceptions like this. And a lot of standard library functions throw, so you need to learn. Yeah, okay, fine. We'll make it a runtime error. A lot of standard library functions throw, and so you need to. It didn't die this time. So, yeah. Okay, so how do you do visualization in bridges using? How do you visualize a binary search tree in bridges? All right, so So did I call it a bonus phase? I think it's extra credit though. All right. So if you go to the Bridges website, what I'm trying to do with this assignment is to teach you guys how to look at documentation. Okay, so if you go to the documentation and go to getting started, you probably know that already. Probably don't need getting started. Tutorials, tree element, binary search tree element. Okay, so demo code, C++ API. Classes, class list, class hierarchy, class index, binary search tree element, like that. And so there's a tutorial about binary search trees right here. Okay, so this is what you need to look at. I'm not gonna give you the bridges code this time. Instead, I want you to look at the documentation, and it's got example code here that shows you it's got binary search tree elements, which are nodes in a binary search tree. it's manually setting the left and the right pointers on them. Just like in Dungeon Delve, you're going to be setting those all manually. You're going to set labels on them. In this case, the label is going to be the letter of the room. You then set the root pointer to be the thing that's going to be visualized. You call visualize on it. And then they clean up their code because they're quality individuals. Okay. So that is that. Okay. So I don't make it too easy for you, but if you take this source code here, copy, paste, adapt to your needs, you should be able to do it pretty easy. Okay. Everything will be done by scratch. For this assignment, I have given you no code. So you're going to have to make a binary tree yourself. You're going to have to construct the dungeon yourself. Search the dungeon yourself. There's demo source code in /public/bst.cc that you can refer to whenever you want. Try doing it yourself, and if you are completely clueless, then stare at my source code and, or post on the help center or whatever. But create the node. That's just the value of the nodes you see when you hover over the dots. Create the node. Create the node. Create the node. No, these are the things that are going to get visualized. The thing that you see when you hover are the labels. So when you label a BST element, that's when you mouse over it, it shows you the thing. And so those labels should just be like A, B, Z, whatever. So they should be BST elements holding a char probably. Is the visualization required? It is 5 points. Yes. You're pretty sure it's extra credit? I don't know, dude. I mean, I think it's 10 points. Yeah. I mean, it says bonus, but it means bonus round. It's not optional bonus round. It is. I mean, it's optional in the sense like you know if you just want to get 5 points, it's optional. So, what did we learn today? We learned how to move constructors. Very important stuff. Rule of zero. We've talked about that before. But again, that's my favorite way of coding. I hate dealing with memory issues. I want the standard library to just handle that stuff for me and call it a day. For this assignment, though, you don't have that opportunity. You're going to have to be doing stuff. You're going to have to be deleting stuff. You're making a binary search tree. So when you're making a data structure, you got to, and that's why these things aren't optional even today. Even though rule of zero most of my stuff, you still got to know it. Get into the habit of doing it. Get comfortable with pointers. Okay. Because they exist. They're real. They're not imaginary. So. Wait, you don't have to make a BST if you're using the bridges code? Sure. Yeah, you can just use the bridges BST for everything if you want. It's fine. You don't have to make your own tree class or node class, right? Each one of these guys got a set left and a set right. Just traverse it that way if you want. Sure. It's extra credit, go off the README. All right, so in that case, the README will change. It'll be required. I'll push out the update for you guys. But yes, you do not have to actually make your own node element. You can just use theirs if you want. Save yourself some duplication of effort if you want. It's not too hard to do either way, but so here's what it looks like after you visualize it. So the number is the weight. And then, yeah. So I would probably use... I'd probably use the letter both for the weight and for both. This is a key value pair, right? That's the key. That's the value. I'd probably just use the letter C, whatever, as both the key and the value. That should work. Okay. you can make it colorful if you want. Change the shapes, change the colors. So, yep. So I'll put this into the README file and I'll make it clear. Then the fun phase. There you go. There. It's not bonus anymore. Yeah, extra credit's not found anywhere within the file. Okay. All right. Solving phase. Quit. Fun phase. Next, you get to visualize it on bridges. Figure it out. There you go. Okay, that's it for today, guys. Thank you. Hope you guys learned a lot today. And we will see you on Wednesday. Start cracking on it now if you can, so that if you have any questions, you can ask me in class on Wednesday. Okay. Thanks, guys.